All right, this is part 2 of our quiz on graphing rational functions. All right, picking up here with number 3, we are graphing a different type of rational function. Promises to be interesting. Okay, vertical asymptotes. How do we find the vertical asymptotes? We set the denominator equal to 0. So that would be like this, x squared minus 4 equals 0. So if I do that, then I could factor this to solve it. It would be pretty easy to do because this is the difference of two squares, x plus 2x minus 2. I also could have added 4 to both sides and taken the square root, but I'm going to do it this way. Setting these equal to 0, and subtracting 2 from both sides gives me x equals 2. Adding 2 to both sides gives me x, when I subtracted 2 from both sides, that gave me x equals negative 2. Adding 2 to both sides gives me x equals 2. So we have two vertical asymptotes, x equals negative 2 and x equals positive 2. So x equals negative 2, x equals positive 2. Okay. Now, horizontal asymptote. How do we find horizontal asymptotes? Well, that's where we have to look at the degree. Is the numerator degree less, equal, or greater than the denominator? Well, in this case, the degree of the numerator is 1, okay, because there's just the 1x. The degree of the denominator is 2, all right, x squared. So the degree of the denominator is greater, the numerator is less, and when the numerator degree is less, then y equals 0 is the asymptote. Okay, and this time there's nothing added on to the end to mess that up. So the horizontal asymptote is, in fact, y equals 0. All right, let's go ahead and graph these asymptotes. All right, there are the asymptotes at negative 2, positive 2, and 0. Okay, now let's take a look at the intercepts. Now, if I want to find the y-intercept, I can let x equal 0. If I want to find the x-intercept, I can let y equal 0. So y-intercept, I'm gonna basically substitute 0 for x. Okay, if I substitute 0 for x right now, okay, that'd be like putting a 0 right here. Okay, and here. Well, so that would just be 0 over negative 4. And 0 divided by anything is 0. Okay, so that means that my y-intercept is 0, 0. Now how about the x-intercept? To find the x-intercept, I let y equal 0. Okay, now a shortcut would be to just let the numerator equal 0. Okay, so x equals 0. So that would immediately tell me that the x-intercept is 0, 0 as well. Now you can only do that when you just have a simple fraction. Okay, this doesn't work when there's like something added onto the end. For example, I couldn't have done this with the previous problem because of the plus 3 is messing it up for us. But say if you did not know the shortcut, you could still just let y equal 0. So this would become 0 equals x over x squared minus 4. But then to solve this, you would multiply both sides by x squared minus 4. So these would cancel out. Okay, so on the right hand side, that's just going to leave you x. But over here, 0 times anything is 0, so you're just going to be left with x equals 0. And that's the same thing that we got when we just set the numerator equal to 0 in the first place. So either use the shortcut or don't. Either way, it's going to be the same thing. All right, so our x and y-intercept are both 0, 0. So let's definitely plot that. All right. And it's time to go ahead and make a table of values. So when you make your table of values, you're going to look at your vertical asymptotes, okay? We're going to need values in each one of the following zones. We need values over here to the left of the asymptote. In fact, let me just be real specific. Okay, we need values over here to the left of the asymptote. Okay, we need values to the right of the, rightmost asymptote. So we need values over here. Okay, and we need values. We need more values than that. We need values on the inside, but the inner left, and we need values on the inner right. Okay, so we need values in each of these 4 zones. Okay, but I'm going to be even more specific than that. So we definitely need these 4, but in addition to that, I want to make sure we have values that are less than 1 away from the asymptote. In other words, I want decimals on the left and right of the asymptote. Okay, so let me show you what I mean. Let's get this going. Let's get it going. Okay, so let's make our, oh, you know what, there's a t-chart down there, but yeah, I'm just going to make my own. So in the yellow zone, I will definitely use, for example, -3. Okay, that's definitely a good value to use over there. So -3 would be good. Let me go one further and use -4 as well. All right, so I'm going to use -4, -3, okay? Now, like I said, I want decimals really close to the asymptote. So the asymptote is at -2, so I want to see what's happening at -2.5. Okay, and then there's the asymptote right there. But I also want to know what's going on just on the other side. So that's -1.5. I want to know what's happening there. Okay, I definitely want to know what's happening at -1. Okay, right in the middle of the purple zone. Okay, we have the x-intercept there. I want to know what's happening at +1. Okay, and again, here comes the next asymptote. I want decimals on either side. So 1.5, I want to know what 1.5 is all about. And then there's my asymptote. Okay, and then the asymptote is at 2, but what's going on just on the other side at 2.5? I want to know what's going on there. And then, so like 3 would be good to have. And 4 as well. I really would like to use all of these values. All these values would be good to have. Okay, and to get these values, I will use my TI-30 XS multi-view. I'm just going to type this in, x over x squared minus 4. All right, hit your table button. Okay, let's clear that out. So I'm going to hit x over x squared minus 4 and see what happens with this mess. Okay. Because I have 4 different decimals I want to look at, I think I'll just use ask x right from the start. Okay, and ask x allows me just to put in whatever value I want. Okay, so I want -4, so I'll just type in -4. Okay, that's -1/3. And then comes -3. That's -3/5. Okay, and then comes -2.5. Actually, you know what? Let me just make these all decimals. Let me not mix this up. So -1/3 is approximately 0.33. Okay, negative 3/5 is negative point negative 0.6. Notice if you highlight it and toggle it, it'll show you the decimal. So negative 0.6. Okay, 0. Now, negative 2.5. Negative 2.5. Okay. That's negative 1.11. All right, I'm going to find the rest of these values off camera. All right, so here are my values. So let's start graphing. At negative 4, we're at negative 0.33. So at negative 4, that's negative 1/3. It's about like this. At negative 3, I'm at negative 0.6. Okay, so it's a little bit more than halfway down. At negative 2.5, I'm at negative 1.1. So negative 2.5, I'm at negative 1, just barely lower than negative 1. Now, at negative 1.5, I'm at positive 0.86. Okay, 0.86, that's almost 1, but not quite. Okay, at negative 1, I'm at 0.33. Okay, that's 1/3. So it's about here. Okay, at positive 1, I'm at negative 1/3, negative 0.3 repeating. Okay, so that's about right here. At 1.5, I'm at negative 0.86. Okay, so that's almost negative 1, but not quite. Okay, at 2.5, I'm at 1.11. Okay, so that's basically 1. All right. At 3, I'm at 0.6. Okay, that's a little bit more than half. And then at 4, I'm at 0.33, which is right about here. All right, so these are the points, all the points from my table. And I really needed all those points to get a clear picture of what was going on. All right, so with all those points graphed, I get a clear picture that this branch is doing something like this. Okay, this part's going to be hard to draw, but I'm going to try. Okay, now this little swerve in the middle, all right, must be doing something like this. Okay, now it must go up from there. Oh wow, okay, that got a little crooked in there. Let me try that one more time. Maybe try it from the bottom this time. Okay, that's better. Okay, and similarly, this one is doing this type of a deal. Okay, so your graph should be looking very much like this right here. All right, now let's talk about increasing and decreasing intervals. So these intervals have got to be read from left to right. Now from left to right, this is a decreasing interval because it's going downhill. Okay, so that's negative infinity to negative 2. All right, because remember, we're just looking at x values here. So negative infinity to negative 2 is what we're talking about, decreasing. Okay, so negative infinity to negative 2. Okay, what else? Now, this entire swerve in the middle is decreasing. From left to right, it's going downhill like a slide all the way down. So negative 2 to positive 2 is decreasing. Okay, so union, negative 2 to positive 2. All right, which brings us to the third branch. Now from left to right, down, 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 down. Another decreasing. So negative 2, from positive 2 to infinity is a third decreasing interval. So positive 2 to infinity. So in other words, this graph is decreasing over the entire domain of the graph. Okay, so increasing intervals, none. There are none. Additional points, we have a bazillion of them. I have more than they even asked for. So this is all set. Did they ask for domain and range this time? No domain and range? Nope. Okay. In that case, let's move on. All right, by the way, if they had asked for the range, it would have been negative infinity to positive infinity, just one interval, unbroken, because of this middle part. Okay, let's go ahead and do problem number 4. Better zoom out. Okay, a little higher order thinking, love it. We need to write a rational function with vertical asymptotes here and here. Let's start with that. Where do the vertical asymptotes come from? They come from setting the denominator equal to 0. Okay, so these have to come from the denominator. Okay, so let's think about that. If the denominator is going to equal 0 and give me this, then I must have had factors like x plus 3, x minus 3 in the denominator. Because if I set those equal to 0, I would get negative 3 and positive 3 out of it. Okay, so this is what my denominator must look like. But let's go ahead and multiply these together. If I FOIL this, well, you recognize this is the difference of two squares, x plus 3, x minus 3. Okay, so this must come from x squared minus 9. Okay, because this is the quadratic that would factor down to x plus 3, x minus 3. So that means my denominator must be x squared minus 9. Okay, so I'm working backwards. X squared minus 9, that would factor this way and give me these vertical asymptotes. Now, where does the horizontal asymptote come from? Well, the horizontal asymptote is all about the degree. Okay, and whether the numerator degree is less, equal, or greater than that of the denominator. Well, they want the asymptote to be y equals 0. Y equals 0 happens anytime the numerator degree is less than the degree of the denominator. So I just need the numerator degree to be less. So there are any number of answers you could come up with here. But you could either let the degree be 1, or because obviously the degree down here is 2. So if you put an x up here, or 2x plus 5, or anything with a degree of 1, that would work. Or you could go with a degree of 0. So if you want a degree of 0, that means a constant. Okay, so you could just put like a 5 up here, or any number. Okay, and that would get it done. So there's any number of viable answers. So either throw a constant up here or something with a degree of 1. And that would give you the right horizontal asymptote of 0. And that's it. Okay, so the denominator pretty much had to be this. But the numerator, anything degree 1 or 0 would have worked here. All right, that is it for this video, and that is it for this entire lesson. We've finished this whole quiz. All right, I hope it was helpful, and I will see you on the next video.